welcome back, guys. So the many friends of you asked doubts about what is in nodal analysis. So I picked one problem for you to solve. So it is about nodal analysis. We'll solve the sum for you. No. Okay, guys. So the question is, the examiner asks you to find by node analysis or node voltage method. Node voltage method. Find power developed and power dissipated by the circuit. So he may ask you to find power developed or power dissipated, or he will ask you to prove the law of conservation of energy, like make the power developed equal to power dissipated. Whatever the type of question you may ask you, but if he asks nodal analysis means you need to do node method. If he asks mesh analysis means you used to do mesh. As you know that any circuit can be solved by either mesh analysis or by node analysis. Okay. If for example, these are two sources. If for example, he asks you to find current flowing through 16 ohm resistor, so the current flowing through 16 ohm can be found by mesh analysis or by node analysis. Okay. Now he directly asks you to find the node voltage method. So in here, one thing is, in node analysis, the major important thing is one node you should keep ground. So let us find how many principal nodes are there here. I said already, just neglect simple nodes. So don't bother about simple nodes, but concentrate on principal nodes. Okay, principal nodes means when two or more elements connected together. So here this is one principal node because this was connected by three elements, these two sources and this source, and we are having this is as a principal node because this is was connected by 2 ohm, 24 ohm, 16 ohm. Again, this is a principal node and this is a principal node. Therefore, we are having 1, 2, 3, 4. 4 principal nodes we are having. Okay. So for node analysis, we need to keep one principal node ground. Okay. So you may keep any of these 4 principal nodes as ground. So my choice is, if I keep principal node, this is a ground, you can consider. But he is asking find power delivered. So take that ground which is near to the sources which are having. So these two sources are there. So I keep this node as ground. Okay, and I name other principal nodes. That is, this is one principal node as V1, and this is as V2, and this is as V3. So for at node 1, 2, 3, that means the V1 is voltage with respect to this ground, the two branch voltages, the two element across the voltage across the voltage source and the voltage across the 2 ohms gives the value of V1. Okay, so what is the voltage V2 means with respect to the ground, the voltage across 3 ohms is V2. Likewise, V3 means voltage with respect to ground, the voltage across the 110 volts and 2 ohms. Now let us, our thing is to find node voltages V1, V2, V3. Okay, how to find at node 1? At node 1, for node analysis, we use KCL and Ohm's law. Okay. So assume currents are leaving at this node. Okay. So the current are leaving at this node 1. So at node 1, KCL at node 1. What is the KCL at node 1? So if the current, this is current, right? So the current, how we'll draw this branch here is, according to Ohm's law, what is Ohm's law? V equal to IR. So I will be equal to V by R. Okay, the current which is flowing from V1 to ground should be in the form of V1. So it should be form of current value. Let us take this is I1, I2 and I3. For example, I1 can be represented as how? V1 minus 110 by 2 ohm. This is the current I1 value. Okay, the currents are leaving, right? So according to KCL, what is the KCL here is I1 plus I2 plus I3 equal to 0. So the at node 1 we need to get equation in the form of V1, V2, V3, that is satisfying KCL. So I1 means V1 minus 110 by 2 ohms. Okay, so V1, why we keep minus here means we should consider at N terminal. Okay, the current is flowing. After flowing, we need to consider, to represent this 110 volts, we need to consider negative value. Okay, and current I2 means voltage at this branch. Voltage means voltage across this 8 ohms is V1 minus V2 by 8 ohms, plus I3 means V1. So I3 means current across this branch, voltage across this branch, that is V1 minus V3 by 16 ohm, that equal to 0. This is so after further calculations, take V1s, all V1s at one place, 1 by 2 plus 1 by 8 plus 1 by 16 minus V2 by 8 minus V3 by 16 equal to 0, equal to 110 by 2, that is 55. So take this 110 by 2. After further solving, you get the equation V1 into 0.6875 minus V2 into 0.125 minus V3 into 0.0625 equal to 55. This is equation 1. So at node 1 by KCL we get equation 1. At node 2, so assume again the currents are leaving here. From at this point, assume currents are leaving. Okay, the current, this current can be represented as, at this current through this 8 ohm branch is V2 minus V1 by 8. V2 minus V1 by 8 plus current through this branch is V2 by 3, because at this ground we consider node is voltage is 0. Okay, again plus V2 minus current through this 24 ohm is V2 minus V3 by 24 equal to 0. So after further calculations, take V1 at one place, you will get the value of minus 0.125 V1 plus 0.5 V2 minus 0.04166 V3 equal to 0. This is equation 2. Okay, at node 3 so this is at node 3. So at node 3, just the beauty here, so we should assume currents are leaving, right? So for each branch we need to find current. So how we will represent the current equation through this branch is V3, so current is leaving, V3 plus 110. V3 plus 110 you need to take. Why will take means current is leaving here. What is the current is flowing? It is leaving here. So that plus point terminal we need to represent. But here I1, the current is eliminating, coming out to this source is minus. Therefore we kept 110 minus. Okay, you need to memorize that like that. So V3 plus we take here, V3 plus by 2 ohm plus V3 minus V2 by 24 plus V3 minus V1 by 16 equal to 0. So further calculation, we get the equation as minus 0.0625 V1 minus 0.04166 V2 and 0.6041 V3 equal to 0. This is equation 3. So now we got V1, V2, V3 we need. So we got 3 equations. Then solve these 3 equations to get solve 1, 2 and 3. How you will solve that equation? Take your calculator and go to equation 3 and in that equation 2 and fill the matrices with V1, V2, V3 values and you will be getting a value of V1 equal to 74.64 volts and V2 equal to 11.785 volts and V3 equal to minus 62.5 volts. Okay, fine. We got V1, V2, V3. Now the actual thing is starts here only. Finding V1, V2, V3 is not a big issue. So we can find whether you got positive terminal, positive values, negative terminals is not an issue. Now our question is how find the power develop. So what is the power, how the power is developed by only the source. Observe what are the source we are having. This is one source and this is one source. Let us take this is P1 and this is P2. Power developed by these two sources. The power developed by this 110 source is how the voltage into power coming out of from this terminal. That means we need to find current, this current. How we will find this? How we will find this P1 current? So I name this as power developed. The current from this source is let us say IA, and the current from this source is let us take IB. Okay, so to represent this is an active element, the current should come out from the positive terminal. Okay, so P power P1 equal to, how you will write voltage V into I, right? P equal to what? VI. So P1 power developed is voltage 110 volts. How the current will be represented is into, so voltage current through this branch is 110 voltage minus V1 by 2. This is the main thing. So represent the value V1 here. So we get P1 equal to a value of 1944.8 volts. Okay. So I am repeating again. We are thinking that this is a source, right? So assumptions of current are in our hand only. So to represent this is an active element, it should current should be come from the positive terminal. Therefore, I represent IA. So IA value means V by R. So current means V by R. How will represent that voltage current here? 110 minus V1 branch voltage. This branch voltage is 110 minus V1 by 2 ohm. Okay, you got that power P1. And again now power P2. How you will find power P2? Now power is voltage into current. So what is voltage here? We are having current 110 volts. Now what is the major thing is here? Current we need to find. How we will find current? IB is a current. So current flowing through this branch. So voltage across this branch is, since current is flowing from here to here, we need to keep V3 initially plus 110 volts by 2. Okay, how we represent plus C here is, we are ending up here current through positive terminal. Therefore, we need to keep 110 here. Okay. So we represent V3 here also, 110 into V3 minus 82.5 plus 110 by 2 ohm. So you got P2 as a value of what is the value of P2 is 1512.5 volts. This is the power developed by this two source. Now the power developed is finished. Now power dissipation. The power dissipation elements is this 2 ohms, that is P2 ohm. So we have a power P equal to what? VI. And we are having VI equal to what? VR. So substitute here. Therefore, we get V square by R. So if you know the voltages across the branch and resistance, we can find power. Okay, what is the power by this source? The power dissipated by this 2 ohms means, how we will represent that? So now we need to find the power voltage across this branch. To find the voltage across this branch, V1 minus V10, V1 minus 110. So why will keep V1 minus? Because we are eliminating, so entire this branch is V1 and 110 volts. To find voltage across 2 ohms, we will have to negativate this 110 volts. That is V1 minus 110 by 2 gives the voltage across. V1 minus 110 means a voltage across 2 ohm. Okay. This is the voltage across this 2 ohms by this 2 ohms. That is the power by at 2 power dissipated at 2 ohms. Okay. So after solving, substitute that V1 value here, you get 225.16 volts. Now your power dissipated by 3 ohms. Voltage across this branch with respect to ground is V2. Therefore, V2 square by 3. We get the value of 46.29, and P 8 ohms is voltage across this 8 ohms. So voltage across this 8 is either V1 minus V2 or V2 minus V1. So I am taking V1 minus V2 whole square by 8. You will get the value of 493.84. Again, 2 ohms, 3 ohms, 8 ohms over. Now power developed by 24 ohm. What is the power developed means? V2 minus V3 whole square by 24. You will be getting the value of 370.4. Okay. Now the power developed by, so 2, 3, 8, 24. So 2, 3, 8, 24 is completed. Now we'll find power developed by this 2 ohms. P2 ohm. What is that value? So voltage across 2 ohms we need. Power developed by this. To find power developed by this 2 ohms means voltage across this 2 ohms. What is the voltage across this means? V3 minus V3 plus we should take. Here to find V3 plus 110 whole square by 2. Solving we will get 378.125 ohms. Again we left volts. Now we will left with 16 volts. V16 means V1 minus V3 by 6 square. So we will getting the value of 1543.3 watts. Okay. Now the power developed by this one source is this one. The power developed by this source is this one. The total power developed is P total developed equal to what? P1 plus P2. So adding this 1944.8 plus 1512.5, you will be getting the value of 3457.3 watt. Okay. Now the power dissipated. So what are the power dissipated by? Power dissipated by what? 2 ohm plus power dissipated by 8 ohm, power dissipated by 3 ohm, power dissipated by 24, and power dissipated by 2 ohm plus power dissipated by 16 ohm. So adding all these things, so power dissipated 2 ohms means 625.16 plus 46.8 ohms means 493.84. Power dissipated by 3 ohms means 46.29. Power to 24 ohms is 370.4. Again 2 ohms is 378.12 ohm, 15 ohm, plus power developed by this 16 ohm is 1543.3 ohm. So adding all this thing, what do you get? 625.16 plus 493.84 plus 46.29 plus 370.4 plus 378.12 plus 1543.3. So adding all this, you got approximately 3457.11 watt. That is, by this, if you see, the power developed is equal to power dissipated. Okay. So maybe this is not exactly equal, but there we can say by law of conservation of energy, the power developed is approximately equal to power dissipated. Okay. This is the thing. So next class we'll solve one problem based on the nodal analysis with depending sources also. Thank you guys.